Welcome back, PCWorld fans. Keith here with another technical analysis. This time we're venturing back to the world of Resident Evil with none other than Resident Evil Village, the latest entry in the franchise. In this installment, we will see the return of the excellent RE engine that powered Resident Evil 7 as well as Devil May Cry 5. However, with this iteration, Capcom has pushed the engine to the next generation with real-time ray tracing support for both global illumination and reflections, each impacting this game heavily in the visual department as well as performance. But that's why I'm here today, to take a look at how AMD's FidelityFX Super Resolution comes into play with Resident Evil Village's performance. I will also compare FSR to the included interlacing upscaling option that was already in the game, something that is very akin to checkerboard rendering. But before we get into that, I want to take a moment and give a short refresher on just what is FidelityFX Super Resolution, or FSR for short. Now, FSR is AMD's open source solution for boosting performance by running the game at a lower internal resolution and upscaling the final image as close to native as possible using a 2-pass algorithm. Now, this isn't a toggle that can be applied to all games like Radeon image sharpening, but is one that needs to be implemented on a per game basis by the developer, like here with Resident Evil Village. Like I mentioned, when FSR is enabled, it runs the game at a lower resolution. How low depends on the FSR setting used, and then takes that resolution and applies 2 passes. The first of which is an edge adaptive spatial upsampling that rebuilds the edges of the objects in the game environment to restore them to near native sharpness. Then it applies a new RCAS, or Robust Contrast Adaptive Sharpening, which attempts to clean up the texture details which is lost in the resolution drop. What you should end up with is better performance without too much cost to the visual quality. Now, with all of that out of the way, let's talk about what makes Resident Evil Village an interesting take on the use of FSR. Now, FSR carries the primary function of increasing performance while attempting to keep that image as close to native as possible, which is good. But what makes things curious in this title is the fact that the game already has its own built-in reconstruction technique that is surprisingly solid. In fact, it's a technique employed by the console versions to allow them to run the game so well. Now, I'm talking about none other than the RE engine's interlaced options. To be quite honest, it's quite an impressive option, but it does have flaws that show up in FSR options as well. Now, just like Red Dead Redemption 2, we find that Resident Evil Village also employs TAA for its anti-aliasing of choice. But here in RE8, it does a fairly good job, except for on the hair. Now, hair is a really difficult feature for TAA to get right without looking like a mess of artifacts. Resident Evil Village does a very good job keeping it all together in the native rendering, but it really falls apart when any other option is selected. The video clip that we're showing is a quick look at a side-by-side showcasing what happens to hair in this game. Look around the image and we can see that the environment and the textures still look quite good on all options, but the hair is noticeably degraded in the interlacing and FSR balanced images. Even the FSR Ultra Quality option is still showing degradation, but not too much. Now, this information will become more important as we discuss performance. For now, I want to step aside and let you see how the game looks in motion as we move down the rendering options. Now, all of this was captured externally using an AverMedia Live Gamer 4K capture card running off a Radeon RX 6700 XT at maximum details, including ray tracing. All that was changed was the rendering methods applied.
Looking for Rose? Man blood. Mother, I bring you fresh prey.
You are so kind to me, daughters. Now, Let's take a look at him. Well, Ethan Winters. You escaped my little brother's idiot games, did you? Let's see how special you are.
Yes, Mother.
Yes, Mother.
Starting to go a little stale.
Then let's devour his man-flesh quickly, Mother.
I am the one who captured him.
Now, daughters. First, I must inform Mother Miranda. But later, well, there will be enough for everyone. Budama!
Hey, wait.
Oh, be careful what you wish for, Ethan Winters.
Wait, what are you doing?
Now that's a quick example of how the game looks in various settings on an inside environment with the characters engaged on screen. But it's also important in this particular title to get a good look at the exterior areas of the game, as much of it takes place outdoors. And the vegetation on the ground as well as the tree branches can make for some difficult scenes for these rendering techniques to work out. So we'll let that one roll now. And that's how things look outdoors. So with all of that out of the way, you have a pretty good idea of what to expect in terms of visuals from the rendering settings here. But the balance of image and performance is the really important part of the equation, and that's what we're about to look at now. For a look at performance, I used the Radeon RX 6700 XT again and ran the game at 1440p as well as 4K with maximum detail settings, including the ray tracing options. One of the key drivers for running features like FSR is to keep the options cranked up while improving performance. And right off the bat with 1440p, we see interlacing showcasing the most impressive games, and FSR gave rather conservative games in this game at this resolution. But what about 4K? Well, that's where things should really shine with performance uplifts, and well, we do. Things look better in terms of performance when moving to 4K, as it makes the 6700 XT quite viable in this scenario when compared to the native option. But again, we see a really impressive showing from the game's existing interlaced options, and if you recall from earlier, we saw that the character shot showcasing the hair issue, the interlaced and balanced options were on par. Later we saw the interlacing option did a very good job handling all the branches in the outdoor scene, and it looks like from the performance to visuals, the existing interlaced option is giving FSR a run for its money in this title. To wrap things up here, I'm presented with a bit of a different feeling than normal. Usually I'm really excited to see what new heights features like FSR or DLSS can allow for games, but Capcom already did a really good job with their interlacing option in Resident Evil Village. Now don't get me wrong, FSR Ultra Quality does a really good job and the performance uplift is good, but Interlaced is able to match FSR balanced in performance at 4K while still looking better and somewhere between FSR Ultra Quality and FSR Quality. So quite frankly, that's where the money is. When I originally played through this game, I did so in my living room gaming PC, which uses a Ryzen 5 3600 and a GTX 1080. I used the interlacing option to play through the entire game at 4K, and admittedly I know that wasn't native 4K, but it looked great despite not using ray tracing. So, while I like that FidelityFX Super Resolution has been added to Resident Evil Village, the more options are always better than less, as I always say. I have to say that the RE Engine's interlacing option is still what I would recommend even over FSR here. With all of that said, have you tried FSR in Resident Evil Village? If so, let us know about your experience and how it compares to the engine's built-in interlacing option for you. Hit the like button if you enjoyed this video, and make sure you're subscribed to PCWorld for more PC hardware and gaming goodness.